Autodesk Moldflow Insight has many advanced simulation capabilities, including that of insert overmolding. Here we have an assembled 3D mesh. Shown in blue is the insert, and shown in green is the overmolding. Also, we've attached a runner system to deliver the plastic into the overmolding component. Let's take a closer look at the insert, which is a 3D mesh. We assign this 3D mesh the property of Part Insert 3D, which allows us to assign material properties. If we were to pick it as a polymer, we could pick any material from the database, or a metal, we can select the metal from the database, or assign its individual properties for thermal and mechanical. So this will allow us to transfer heat to and from the insert during the simulation, as well as calculate the deflection from a warpage simulation. Let's take a closer look at some of the process settings. Many of these process settings are similar to regular thermoplastic injection molding. We have our filling control and packing controls, and then our warpage calculation. So the warpage again will take into account both the overmolding and the insert. As we take a look at some of the results, the first of which is fill time. Fill time shows the progression of the plastic coming into the overmolding, flowing around the insert. During this progression, you can see race tracking happening in the thicker areas, hesitation through the thinner areas, and then as it race tracks around, you'll see a possible defect called an air entrapment. So the air entrapment is where air is trapped in the mold, cannot escape. We can visually enhance that, show the result of air entrapment over top of the filling patterns. So this could potentially avoid one of the pitfalls of producing this part. Another output is temperature. So with temperature, we can take a cross section and show the temperature influence with the insert. We can then move this cross section around and even animate the temperature display. So we see the material coming in very nice and hot, the insert much colder, possibly at room temperature, but as the progression of the flow passes the insert, it actually adds heat to the insert, increasing its temperature. And we can see this throughout the entire cycle. If we want to take a little closer look at this, all we need to do is take off of our cross section, and if we wanted to, we can show just the insert itself. So we turn off the part tetras, which will leave just the insert and the runner. And then if we back up our animation, show this again, we're seeing just the temperature influence of the plastic to the insert itself. So if this were a critical component that couldn't get above a certain temperature, we'd be able to easily see if that was possible. We can show this type of information in many different ways. Here we're showing a temperature plot. Choose an XY plot. And then we can pick several locations. And what we're going to see is the temperature over time for the insert to plastic connection. So if we are looking for certain adhesion qualities, we can see if those have been met or not. And let's go ahead and turn back on the part, and we'll bring up another plot called the freeze time. So it's important to know that we're packing the part out for the length of time that the gate stays open. So we can actually bring up a freeze time plot and show it in a method that we're animating the freezing over time. So initially, as the part is freezing, we see that the material is dropping off to its transition temperature and going back to a transparent color. So if we advance through this, here we're in the packing phase, shown by the time up here in the right, and as we advance it further, we show the gate area starting to freeze off, and there it froze off, but many areas of the part are still left unpacked and still above transition temperature. So if we wanted to, we can actually take a look at the volumetric shrinkage in those areas and ultimately see how it's going to impact the overall warpage of the part. So volumetric shrinkage, we can again take a cross section and see internally to the part all the different areas with high shrinkage and possibly voiding conditions within the part. And lastly, if we wanted to, we could take a look at the actual deflection of the components as they're molded together. So here we show a deflection, includes the insert and the overmolding, and we can see how the two interact with one another. So you can see how the insert overmolding analysis can give you very valuable information to understand how a design will be manufactured.